Welcome to the course Ergonomics in Automotive Design. Today we are going to discuss our module 4, that is automobile control and displays. So, in this module we are going to discuss few topics. First one, in vehicle control and displays. Second, characteristics of good control and displays. Third one, principles of control and display design, and the last one, usability evaluation of in vehicle control and displays. So, first topic, in vehicle control and displays. F.L. Farad 1907 in his book A Busy Man's Textbook on Automobiles mentioned that the general trend of motor car design is to make a machine which will be practical, comfortable and serviceable. So, from this reference we understand that the consideration of ergonomics in the design and development of driver vehicle interface was initiated long back as early as 1907. Now, in the vehicle there are different types of controls and displays, and some of these controls mainly serve as only control, fewer only displays. On the other hand, there are also mixed control and displays. For example, control with labels or signs, touchscreen interface. So, these are coming under the example of mixed control and display. Harvey and Stanton 2013 mentioned that driving is a complex multitask activity consisting of interaction between the driver, the car and the environment. It requires the successful integration and coordination of driver's cognitive, physical, sensory and psychomotor skills. Now, if you look in any of the vehicle and its inside in vehicle various displays and control, then we will find there are steering wheel. So, this steering wheel is one control for vehicle navigation. There on the steering wheel there are also some remote controls for various types of operations like AC control, then audio systems control. So, this type of controls are also available on the steering wheel. Apart from these controls, there are also so many other controls on the central console. So, here are different types of knobs, buttons, there is gear shifter. Similarly, there are also various types of foot controls, brake, accelerator, clutch. So, these are present inside the vehicle. Apart from these different types of controls, there are also displays. Through the steering wheel, we can see different instrument cluster. So, where there is speedometer, fuel gauge. So, this type of displays are there. Similarly, on the central console, we can see this type of touch screen with infotainment system. So, inside the vehicle there are different types of controls and displays which are very much essential for driving as well as non-driving tasks. Now, all these controls and displays are associated with different types of in-vehicle task performance. Some tasks are related to primary driving task, some are related to secondary driving task. So, which are the primary driving tasks and how in those primary tasks different types of controls and displays we will discuss. So, primary driving task, what are those primary driving tasks? Continuously monitoring the driving scene. Second, maintaining the safe control of the vehicle by guiding its position, that how that vehicle will be navigated on the road. So, that has to be guided by using different types of control operation. Detecting and responding to various types of hazards, and you have to take precautions so that there should not be any accident or near to accident cases. Navigating by steering, accelerating, braking, speed choice, lane choice and maneuvering in traffic with instant decision making. So, while drivers are driving, they have to make instant decision and accordingly they have to operate various types of control and they have to maintain the speed, maintain the lane to avoid any sort of accident or mishap. Finally, the ultimate goal of this driving task is to reach to the destination safely and comfortably. Now, what are the secondary tasks performed by drivers inside the vehicle? So, these tasks are not directly related to driving. The purpose of this task is to enhance the driving experience while addressing the driver's need, then provide informations about the journey, the vehicle in the form of navigation, instruction, traffic information and vehicular data which enables the driver to make better informed decision about the journey and therefore, to improve the efficiency of roadway use. So, there are various references mentioned where from we got this information. Then it provides entertainment including audio features such as radio, CD, MP3 and even visual media including TV and DVD. So, these various controls and display also helps in communication via voice calls and text messages. Now, for performing these types of in-vehicle primary tasks which are related to driving or secondary tasks which are not directly related to driving, for performing these types of driving and non-driving tasks, different types of controls and displays are present inside the vehicle. Now, what are the ergonomics challenges for in-vehicle controls and display design? Secondary tasks are not directly involved in driving and performed for the control of infotainment, comfort, navigation and communication functions. Cars are now constructed to make driving safer than ever, but the act of performing secondary tasks within the vehicle remains a significant threat to the driver's safety. Interaction with secondary tasks is a potential cause of in-vehicle distractions because it can increase the demand of the driver's visual, cognitive, auditory and physical resources, and this may result in reduction of the driver's attention to the primary task of driving. And that is why when the driver's attention is diverted and where there is distracted driving, then there is chance of error and accident. With the advancement of technology, complexity of in-vehicle information system are increasing rapidly by exceeding the human capabilities. This is likely to result in an increase in driver distraction as mentioned by Walker et al. 2001. Now, if we look in this image, so there are different zones or place. Now, if we look to this image, then we can find various zones to place the controls and displays in relation to the driving posture of the driver. So, while driver is seated on the driving seat and adjusting the seat forward and backward, then which are the area or which are the zones where most of the controls and displays to be kept for various purposes, that we need to be decided. Now, from this image we can see this line, this curve is for minimum reach envelope. Similarly, this line is the maximum reach envelope. So, this is the minimum reach envelope for the drivers as well as this is the maximum reach envelope. Then next important aspect is the visible zone through the steering wheel. So, this area, so upper part of the steering wheel through the steering wheel rim and at the up of the steering wheel hub there is a space, through that space we can see the instrument cluster. Next 35° down angle zone. So, this is the horizontal line of sight, below that 35° area. So, this is another area. So, these are the various zones. Based on this zone we have to decide where we should keep our different types of controls and displays to make the driving experience comfortable, easy and safe. Space available to locate controls and display is bounded by space rearward to the maximum reach, space forward to the minimum reach, then space above the 35° cone and visible region seen through and around the steering wheel and the stalks. Now, if we go back, so first we should know what is this minimum reach envelope. So, while the driver with shorter body dimension adjusting the seat at the forwardmost position in moving the seat in forward direction, and at that time while the 5th percentile driver's upper arm is parallel with the seat back and elbow is on the side bolster of the seat back, at that moment based on the elbow making it as the pivot point, the area or the volume which can be accessed by the lower arm, that area or that envelope is called minimum reach envelope. So, minimum reach envelope is actually decided based on the access area or reach capabilities of the 5th percentile driver by their lower arm, while starting point is the or pivot point is the elbow joint on the seat back bolster. In this situation, this volume can be accessed by the 5th percentile driver. Now, during this minimum reach envelope, we generally consider the grasp reach or grip reach, so that all these controls which we want to position, that should be positioned beyond this zone, because if that zone is the distance from the driver seat, if that is less than this envelope or this horizontal distance, then what will happen? It will be difficult to operate by the 5th percentile driver, as well as obviously for the drivers with larger body dimension and with larger hand dimension. Next area is the maximum reach envelope. So, while we are deciding which will be the maximum reach envelope, for that purpose we need to position 95th percentile mannequin on the seat, and the forward 3 finger arm reach, while the driver is 95th percentile driver or driver with larger body dimension, adjusting their seat at the rearmost position and sitting on the rearmost position while they are extending their arm forward. In that scenario, the 3 finger reach area is denoted by maximum reach envelope in different direction, sidewise direction, forward direction, as well as upward direction. So, ultimately in the 3D space, the area or the envelope covered by this maximum arm reach, that is called maximum reach envelope. Now, while we want to position different types of controls or display, then we should consider this particular zone between the minimum reach envelope as well as the maximum reach envelope. So, these are the boundaries. So, this is the lower boundary for positioning the control and display, at the same time this is the upper boundary. So, all the controls and display which are frequently used, those controls and displays should be positioned within this zone, mean this is the lower boundary and this is the upper boundary. So, within the middle zone should be considered for positioning various controls and display. So, this is the maximum reach envelope and the minimum reach envelope, and between this reach envelope, that space is used for positioning the control and display. Next is the visible zone through the steering wheel. Now, if we consider the 95th percentile eye ellipse, and from that eye ellipse if we draw these types of line of sight, you can see this dotted red line. So, the space between these two dotted line which is going through the upper portion of the steering wheel. So, this area is actually used for the purpose of positioning most important displays, so that driver can easily visualize during driving. So, while the driver is looking straight forward on the road, only with the minimum eye movement they can easily see the instrument cluster through the steering wheel. So, this area is decided based on this by making this type of tangent line from the 95th percentile eye ellipse. This is the upper boundary and this is the lower boundary. Now, next important zone for positioning other displays and control, that is 35° downward angle zone. So, from the center of the eye ellipse, if we draw a straight horizontal line ahead, this is mentioned as HH line, and from that line if we go 35° downward. So, this zone is actually the area where we can position most of the important displays, as well as the various controls which are frequently used and which cannot be operated without looking at. So, the various controls and displays which cannot be used, or the controls which cannot be operated blindly. So, in that case, for easy visibility, this is the best location, because while the driver is looking straight forward on the road with minimum eye and neck movement, they can easily look at the various controls and display positioned within this 35° downward zone. Now, inside the vehicle there are numerous controls. Here is the list. This list is adopted from the Vishesh book, which is published in 2016. So, from that book, these are the we have listed various controls used in the automobile, with different types of automobile vehicles. So, one is momentary push button, latching buttons, touch buttons, radio buttons, multi buttons, mode selection, multi button, directional, momentary rocker, latch rocker, hinged pull up, push up rocker, continuous rotary, detented rotary, continuous thumb wheel, detented thumb wheel, then different types of stocks, stock rotary, continuous, stock rotary, detented, toggle switch, slider continuous, slider detented, levers continuous, lever detented, joysticks. So, this type of various controls are available inside the automobile, and those are used by drivers for various purposes. Now, if we take specific example of specific types of controls, then first we are discussing about continuous versus discrete control. So, what is continuous control? In case of continuous control, we can operate that control switch or control in such a way that its setting goes continuously. There is no specific position. So, while we are moving the control, the entire range of motion is actually giving different control settings. So, example of such controls are the rotary control for temperature regulation, then various slide switches and levers. On the other hand, if we think about the discrete control, so in case of discrete control, there are some specific position or detented location where we have to set the control. So, that is not continuous. So, we have to set at this particular position to achieve the particular settings of that control. So, these types of control include rotary controls for fan speed regulation. Here is the example of fan speed regulator, which is rotary control. So, this is the off position, then when you are starting, gradually you can increase the fan speed by moving clockwise. There are other types of discrete controls which include detented, slide controls, rocker switches as well as gear shifter. Now, apart from this continuous and discrete types of controls, there are different push buttons, and these push buttons are available in the central console as well as on the steering wheel. So, now here is some example. These are the number for dialing different types of number or changing different types of settings. So, all these are the push buttons. So, you can see these are the push buttons. So, if we press this particular knob, so then it will be on and off, then this audio system will be operated by this one. Similarly, if we move it clockwise or anti-clockwise, accordingly volume can be increased or decreased. So, here this is also, while we are using this for on and off, then this is acting as a push button. Similarly, there are so many other types of push buttons. Since many push buttons or touch buttons can be activated by very little force, so there should be some provision so that hand or palm can be rested near that buttons. So, within the hand and finger is distance of the button. Now, there are other types of controls like touch screen and voice control. So, in touch screen, control surface overlaid on the top of the display. In case of voice control, the voice recognition system allows recognition of the driver's spoken word and sets system functions. So, this is very much useful for hands-free operation. So, only by the making some particular word or particular sound, we can activate different types of controls and execute the task. Some limitation of the voice controls. Drivers may dislike this type of controls because they may feel that okay, they are talking with the instrument or the non-living objects. Next, temporary disability in voice generation, easy for in case of sore throat, then the driver or the person who is driving the vehicle, he cannot pronounce a particular word or particular instruction properly. As a result, device may not be activated. Then noise in the vehicle may reduce the accuracy of the voice recognition system. There may be delay in voice recognition and also error in voice recognition. So, different types of limitations are also there in case of voice activated controls. But on the other hand, there is also so many benefit, or there is also some advantages, as we already mentioned. This is good for hand free operations. Now, in case of touch screen, now in majority of the advanced vehicle, there is touch screen in the central console panel or for different types of other displays also for navigation purpose, for infotainment purpose. So, in that case, this touch screen, in one hand there are various advantages, on the other hand there are various disadvantages also. So, if we look into the advantages side, so first this input device itself act as the output device. So, there is no requirement for separate input and output device. So, the touch screen which is displaying different types of visual information on the same screen. We can, by pressing or touching, we can operate the control. Reduces the hand and eye movement needed to find the touch oblique grasp control. Eliminate motions for finger bending and grasping. Next, no extra input device or packaging space is needed in this case, because as we mentioned, this is the same surface, same display screen is actually act as the control also. Now, there are also different disadvantages. So, firstly, obstruction of the touch area due to operating fingers and the hand, and due to this obstruction it is difficult to operate. Then a broad fingers contact does not allow for fine controls in the touch screen, and for movement or for operation of the fine controls sometimes people may find difficulties. The lack of tactile feedback in conventional touch screen, but in the advanced touch screen this type of tactile feedback is being provided now. Then reflections or glares from the screen will reduce the legibility, particularly during daylight or in a condition where there is light directly falling on this type of touch screen interface, then there is problem with the visibility of information or legibility of that display. Capacitive touch screen will not work with glove hand or pen stylus unless it is conductive. Finger touch can cause prints or smudge marks on the display surface. Now, there are also other types of controls like rocker switches, different types of switch for on and off. So, if we press one side, then another side will be protruded, and when we press another side, then the opposite side will be protruded. So, based on that we can understand whether that is in on and off position. Otherwise, we can move different types of rocker switches left to right, also this type of buttons for switches for horn. So, these are the examples of rocker switches. On the other hand, there are different types of rotary switches. So, rotary switches, as this is the example of fan control. So, when this knob is rotated clockwise, then we can increase the fan speed, and while we are moving it in anti-clockwise direction, then we can reduce the fan speed and we can off that fan also. There is also multifunctional switches. Here is one example. So, this is for the control of the AC vent, the direction of the airflow, whether it will come from the front and towards the leg. So, different types of, so if we rotate this control, then we can set at different positions, and accordingly we will be able to achieve different types of settings. To indicate various available functions, visual labels and additional cues, shape, texture, color, orientations are provided on these controls. So, this is one example of this type of multifunctional switches. Same switch, but based on different settings we can achieve different types of operation. Another type of controls is programmable or reconfigurable switches. The side view mirror control switch, if we see this particular one, so here we can hold it, we can rotate it. Based on the rotate we can select whether we want to control the left side or right side window, and after selecting that one, then it acts as the, from its base it acts as the joystick, and based on that joystick movement we can control the setting of the or angle of the mirror. Then there are also left side and right side stock control with the steering wheel hub. So, in that case the stock controls, this is also reconfigurable switches. So, there are various positions we can move it in forward direction, backward direction to achieve different control settings. Similarly, say particularly in this example, while we are thinking about this stock control for wiper for windshield cleaning. So, there are on and off function for the rear windshield wiper. At the same time, if we move this one in different forward and backward location, we can control the wiper on the front windshield. A programmable or configurable switches can change its control function depending on its selected mode. So, these are the different modes. Based on the mode selection we can achieve different functions. Now, there are also haptic controls. So, these haptic controls are actually providing cues. So, without even this haptic controls help, without looking at the control we can feel it, we can touch it, and accordingly we can perform the activities. So, generally programmable switches, that can change their function and tactile feel characteristics. For example, force deflection profile, feel of detents, gain and activation direction. So, by this different types of haptic controls work. So, here one example. So, for force direction, whether we will move upward or downward to operate the control switches for side windows. So, on the door trim panel, this type of controls are there for operating the side windows. So, in that side windows, operating that or controlling that side windows up and down, we can move these control switches upward direction, then window will also move up. At the same time, if we move in downward direction, then window will go down. So, this type of buttons are or control switches are available, which actually give haptic feedback of control operations. So, apart from these various types of controls available in the automobile, there are also numerous types of displays available. So, here is a list. So, static symbol or icon used for identification, static word label, analog display with scales and pointers. There is also analog display with bars, bar display, then digital display, graphic display with pictures or camera views, changeable message display, color change indicator, then programmable or reconfigurable displays, auditory display like beeps, tones, buzzers, voice message, different types of sounds come from this type of display. Now, if we go for specific type of display, static versus dynamic, what are the static display, what are the characteristics of this type of display and what are the characteristics of dynamic display. So, in case of static display, various information which is being provided by the display, that is static. So, it does not change over time. So, different types of written material against the controls that act as the labels that act as the static displays. So, here are some examples: written USB, then audio store, display. So, this type of written information near the buttons is actually coming under static display. On the other hand, while the display is giving the information dynamically, it means with the time that displayed information is being changed. So, here while the speedometer pointer is changing its position from 0 to 40, 60 like this way. So, while there is a change in the displayed information based on the speed of the vehicle, then this is we consider as the dynamic display. So, speedometer is actually used for dynamic display. Then we can categorize this type of displays in two categories. One is quantitative display, another is qualitative display. In case of qualitative display, the information is actually provided in qualitative format, means there is no particular value, only it indicates the change direction. Say for example, this one fuel indicator. So, here E for empty and F for full. So, whether the fuel inside the tank is towards the full or towards the empty, that is indicated, but exactly how much is the amount, that is not denoted here. So, this type of display is coming under qualitative display. On the other hand, while the speedometer showing a particular speed, say 40 km per hour based on the pointer location, then we consider that as the quantitative display. So, that is providing a particular value. So, inside the automobile we find both qualitative displays as well as quantitative display. Now, symbolic or pictorial graphics. So, inside the vehicle there are different displays which actually indicate or convey the information through different types of symbols or indicators. So, for example, here you can see the symbol for seat belt, symbol for the battery, symbol for the engine, symbol for the oil or fuel. So, this type of different types of information is actually displayed by symbolic or pictorial graphics. Then dedicated versus programmable. There are also displays which are for a particular purpose. A speedometer is only used for showing the speed of the vehicle and it does not have any other function. But on the other hand, if we look at this type of audio display, this is programmable display, because audio system, it can act as the based on the selected mode. If we select the CD player, then it will show music track. If it is FM or radio, then it will show the channel setting. So, same display, but in different mode. If we select CD mode or radio mode or FM mode, based on that it will display different information. So, this type of display we consider as the programmable display, and it is actually the same display used for multiple purpose, but in case of speedometer this is dedicated display, only one type of information it is showing. Then there are visual display based on the different types of our sensory modalities, vision, audition, touch, then olfaction. So, based on the different types of sensory modalities, again we can categorize in vehicle displays into different categories. So, speedometer, it is coming under visual display because it is showing the visual information. Then audio system, from the audio system different types of music or different types of sound is coming. So, this is considered as the audio display. Then there are surface, there are this type of controls for controlling the windows. So, this type of controls are available on the door panel. So, these controls are actually coming under tactile display. When you are touching that controls, through its shape, through its sizes, through its texture, it is actually giving information that which type of or which control is there. So, we need not to look at that one. Only by touching or only by feeling we can understand the control type. So, the surface, shape, size, grip, texture or vibration of the grasp or contact area of those controls is actually giving us the information, and that information is the tactile information. Then if we consider the smell of the leather of the seat cover, then that is actually olfactory display. So, the information is coming through the olfactory sense or olfaction. Now, we are going to discuss about head down versus head up display. So, first we should know what is head down display and what is head up display. So, if you look at this image, then while driver is looking straight forward, below that straight forward line of sight, if we go up to 35 degree down, generally it is actually starting from first 15 degree, this is for outside visibility. So, from 15 degree downwards to up to 30 degree downward, this angle is actually used for head down display. So, all the displays located on the dashboard, then central instrument panel. So, these are coming under the head down display. While drivers are looking toward these displays, then eye movement is required, and if the line of sight movement is more than 20 degree, then not only eye movement, there is also complementary head movement. So, using both eye movement as well as head movement, drivers actually visualize all these displays located on the dashboard or at this central instrument panel viewing through steering wheel. On the other hand, if we talk about the head up display, head up displays are generally positioned from the straight ahead line of sight 15 degree down or at the most 5 degree upward. So, not only 15 degree down, but at the same time 5 degree upward. So, this zone is actually used for the head up display, and head up displays are generally electronic display. While drivers are looking at the head up display, then there is no requirement of eye movement or head movement. While they are looking at the road scene, they just can change their eye accommodation or focusing on the image projected as the head up display. Now, if we look at the second image, this right side. So, this is the example of head up display. In head up display, as I already mentioned, these are the electronic display, that image is actually projected on the windshield, but at which distance? The distance is generally towards forward of the vehicle near the bonnet at the bumper. So, at this distance these displays are projected, so that the driver can easily look at that displayed information without moving their eyes from the primary driving scene. Only what they require, they need to change the eye accommodation. So, for that purpose we know that there is a capability of our eye lens which can change its focal length by the contraction of the ciliary muscles. So, based on the variation of the focal length of the lens, drivers can easily accommodate the visual information and accordingly can perceive that visual information. So, there is no requirement of shifting the eyes from the road, at the same time there is very minimal requirement of neck movement. Now, if we moving to the next slide, so this is related to advantages and disadvantages of the head-up display. So, first we are discussing about the advantages. So, there are various advantages of using head-up display. It reduces the off the road time of the eye glance. Second, elimination of the refocusing and eye axis convergence movements and eye accommodation time. Third, more time is available to be spent on the road scene. So, these are the various positive points for the head-up displays. On the other hand, there are also some disadvantages. First one, the target can be masked by the head-up display image. Second one, projected image may not be visible over brighter background in sunlight or in daylight condition, bright daylight condition. Poor optics can cause the annoyance. There may be double images. So, while drivers are looking at the head-up display, due to the poor optics, he may find double images, which may create annoyance for him. Then attention switching, distraction and visual clutter. So, while in the same visual scene where the driver is looking on the road, on the same visual area or view field, while these types of images are projected from the head-up display, then it may create visual clutter and it may also lead to visual distraction from the primary scene. Then there is possibility of cognitive capture, that is captures driver's attention under less demanding condition. Now, while we discussed about various types of controls and display, we should also know what are the characteristics of a good control or a good display. So, we are going to discuss about the characteristics of good control. So, any control, if we consider this is a good control, it must have requirement of minimal mental and physical effort required to get the information or to operate that control. Then easy to locate the position. So, where the control is located, for that purpose there should be minimal visual search. With minimal visual search, we should be able to identify the location of the control. Next, easy accessibility. Any control, or if we mention this for a good control, any control activation should require minimal hand and finger movements along with the minimal torso movement. So, whenever the driver is going to access a particular control, his hand movement or finger movement, at the same time gross body movement should be as less as possible. Then the control and its function should be self-explanatory. It means control should provide visual or any other sensory cues regarding its intended function and mode of operation. So, in this context, it is important to know about the Gibson's theory of affordance. So, according to Gibson's theory of affordance, that the product or the object should give visual cues that what will be the possible way of action. The same is also applicable here. While you are designing the control, for a good control, it should be self-explanatory for its function and mode of operation. According to the use context, the control design should favor its under its use varying condition. For example, traffic level, road condition, weather condition. If the weather condition, say if the illumination level is low or it is raining, in all this scenario also the control identification and control operation should be easy. So, those aspects we need to consider to make a control good one. The characteristics of good display. Here also the good display should involve less effort. Minimal mental and physical effort should be required for accessing or receiving the information from the display. Easy to locate the position like a control also. In this case, for display identification or identifying its position, there should be very minimal visual search. So, minimal number and short duration of eye glances should be needed to identify the position of the display and receive information from that. then there should be minimal gross body movements for acquiring information from the displays. For example, there should be minimal eye movement, neck movement and torso movement. So, in this case, if we use auditory display, head up display, then there is obviously requirement of less eye movement or neck movement, and at the same time obviously there is almost no requirement of gross body movement. So, we can, if it is auditory display, we can hear without changing our body position. If it is head up display, then we can visualize the displayed information with minimal eye movement, neck movement or gross body movement not required. Then provided information should be precise and easy to understand. Display should provide only the required information to avoid cognitive overloading, and the information should be easy to understand for drivers with varying socio-cultural background. So, whatever information is being displayed, that information should be easy to decode for the driver, because the driver may be from different socio-cultural background. So, displayed information, its language, its way of presentation should be easy to decode by the drivers.